this video is going to walk you through the last 3 exercises of the annuity exercises spreadsheet. As before, we're going to use previous material whenever we can. So if you need to watch that video, that's the previous video that walked through the first 3 exercises. In this case, for exercise 4, we're going to value receiving $90 for 3 years, starting at year 3, but now we're going to value it as of time 9. All right, so basically we're going to do a future value of this at time 9 based on cash flows that occur in years 3, 4, and 5. All right, so let's start out by going to the previous exercise. We're going to take our model there, we're going to copy that and paste it in our new spreadsheet. All right, so in this spreadsheet, we see our cash flows are in the right spot. They're in periods 3, 4, and 5, so that looks okay. But now the value of $1, we need to specify these at time t equals 9. Right? We don't want them at time 0, which is what we have right now. So we need to push these forward 9 years. So the way we can do that is we can take this whole formula we have in here, we can put it all into parentheses, and now multiply it times 1 plus our discount rate. F4 to lock that cell, raised to the, how many years do we need to move it? We need to move it 9 years. So our value period is 9. We'll lock that reference. And now we see that the cash flow at time 0 moved forward 9 years is worth $2, not $1. And if we copy that down, now we see that the values early on have all increased to more than $1. Now where is our sanity check here to make sure we did this right? Well, it's at time 9. Because $1 in period 9 and period 9 value should be worth $1, right? So that's where we're making sure everything in the model is working. We see that we get $1 in year 9, so that looks good. So now we should come over here, get the present value by adding these all up. Again, this is the present value at time 9, and there we have the correct answer. Now, just like we used last model, we're going to do the same thing with our math annuity calculation. So I'm going to my math formula. I'm going to copy that, come over to exercise 4, paste it. But now the problem I know is that I don't want time 0 value. It's the same thing that we just did in the other case, is now instead of time 3, I want to move this forward. 1 plus r. And I want to move it forward 9 years. So we can come over here to the 9 years. And now that's all we've done is we've taken a time 0 annuity, moved it forward to a time 9 annuity by moving it forward 1 plus r to the 9 years. And here answer 4 is correct. Now, exercise 5, we're going to do kind of a different version of exercise 6. All right, so in exercise 3. In exercise 3, we were getting that annuity for 3 years. The difference now is that it's going to grow every year, which means we're going to have a little bit different formula, which I'll get to in just a second. The other thing I want to point out is that both in exercise 3, exercise 4, and exercise 5, that present value formula, the PV function in Excel, we were not able to use that anymore. It doesn't have the ability by itself to move these cash flows around in time. You could always move them around the same way we were doing with our math formula, but there is no built-in Excel function to do these calculations all by themselves. All right, so for exercise 5, we're actually going to back up to exercise 3 and grab that model. So let's go back to exercise 5, paste our model here. We're going to set up our sum. It's not going to work quite yet, but we'll get there in a second. All right, so we see 198 was our original value. Now it should be 206, and that's because the cash flows should grow. Over here we have 90, 90, 90. Instead, we want 90 plus 4%, right, our growth rate up here, and then plus 4% again as we go to that 5th year cash flow. So we need to find a way to build in that growth into our cash flow formula. And since our cash flows are in the right spots right now, we don't want to mess with the AND function. But what we can do is we can change the cash flow amount. So here we have cash flow 4, or sorry, C4 is where our cash flow is. And now we want to grow it. So we can grow it by multiplying it times 1 plus our growth rate. So our growth rate in this case is our 4%. Make sure you lock that. Whoops. I actually typed it wrong, so I hit escape to get out. Let's go back in. We're going to do times 1 plus our growth rate R, F4 to lock the cell, and hit enter. Now we can copy that all the way down, and we don't get exactly what we want, right? Because in this case, we grew at 4%, but that's all we want for the middle cash flow. The first cash flow should still be 90, and the last cash flow should be something more than 94. So we need to adjust for that. So how can we adjust for it? Well, we got to use the exponent, because every period it grows, we can basically compound that. So in this case, to compound this 1 plus R, what we can do is we can take the starting period, right? We know it starts in period 3, so we can take whatever period we're in. So that would be cell C14, and we can subtract the starting period, C7. So in this case, since we're in period 3, and we're going to subtract 3, that means we're going to raise this to the 0 power. 1 plus R to the 0 is 1, so we won't get any growth. Next period, it'll be year 4. 4 minus 3 is going to give us 1, so we'll get the cash flow times 1 plus R to the 1. The following year, year 5, right, we're going to have 5 minus 3 is 2. So cash flow 90 times 1 plus R squared is going to give us that 2 years of growth that we want. So we hit enter. Now we need to copy this formula over the entire column. And now we see our 90, 94, and 97 that we wanted all along. Let's check our answer. And we see that our answer is correct. All right, now we want to do the math formula. And here it actually gets a little bit trickier. We need a new formula because we had a present value of an annuity. Now we need the present value of a growing annuity. And this formula is going to change a little bit. Right? It's basically just incorporating G, or our growth rate, but we do have to note what it is. All right, so here we're going to say present value at time 0 is still equal to cash flow 1 times something. Let's be 1 minus 1 plus R divided by 1 plus G to the minus T, all divided by R minus G. So our formula changes a little bit. Now let's go ahead and type that in. So we're going to type cash flow times, again, pay attention to your parentheses, 1 minus 1 plus R divided by 1 plus G, close both parentheses, raised to the minus 3 periods, divided by R minus G, and we get 240.86, and we say, oh, what wasn't right here? Well, we got the present value of a growing annuity formula correct. What we haven't calculated in, though, is the starting period, right? We didn't start at period 1, we started at period 3. Because of that, we have to come back in and adjust. So we're going to take that whole thing and wrap it in parentheses so we don't screw up any of the calculations, and divide by 1 plus R raised to the number of periods, starting period, minus 1, just like we did previously. And now we get that same answer, that 206.49. All right, for our last exercise, we're going to change approach a little bit. We're not going to deal with annuities, but instead we're going to talk about perpetuities. The difference between an annuity and a perpetuity is that the annuity's cash flows stop. In our last few examples, they stopped after 3 years. Perpetuities, on the other hand, go forever. All right, so as a result, we're going to have a little bit different formula, and I'll start out giving you that. So the first thing we see is that we get the present value of an annuity formula. Present value at time 0 is equal to the cash flow starting at time 1 divided by R minus G. All right, if you don't have a growth rate, that's okay. That G can be 0. In this case, we do have a growth rate. So you subtract the growth rate from the R and take that amount, use that to divide the cash flow, and that'll give you the present value. All right, so let's go ahead and first we're going to try that formula. So let's come over here. We're going to do our formula as equals cash flow divided by R minus G. We hit enter. Again, we're a little bit off. Why are we off? Well, we haven't accounted for the fact that the cash flows don't start at time 1. Right, so we have to make that adjustment again. Divide by 1 plus R to the starting period minus 1. And now we get our 192901. So everything's good on the actual calculation. Now let's do that same calculation in the model. And importantly, we can't do the exact calculation in the model. And the reason is we can't model cash flows forever, right? Excel ends. It turns out it ends at like 1,000,000 rows. So we do have plenty to get a very precise estimate, but it does end eventually. So we cannot model infinite cash flows. But we can approximate it pretty darn close. If you notice here in my answers, right, you have a correct answer of summing over 100 years, right, 100 years of doing this. And there we see that, well, we end up $44 close, right? We're $44 off in our approximation, right? We're going to build the model to handle 100 periods, but allow even more. And we'll see what happens as that approximation error changes as we increase the number of periods. All right, so let's go ahead and start with our cash flows. We're going to take that same model we had before with our growth rate. Let's take this, copy it over. Our parameters moved just a little bit in this case, so we have to adjust them. You always have to be careful about that. In this case, our cash flow moved, so I'm just going to pull that down for the discount rate. Now our present value formula looks okay. Our cash flow, notice it moved up here, so we got to pull our cash flow down. Let's see if that works. It almost worked. We have to check again. Let's see, our growth rate is in there now, so we have to make the adjustment for that. And our discount rate moved a little bit. So we know that the starting period has to be greater than or equal to 3. That looks okay. But here we got to have C9 instead of C6. So now we see that we get $90. It grows. And it stops in year 18. Well, we got to copy that down a little farther now. We're doing a lot more of our model building. Let's allow this to go out about 1,000 rows. 700 or 800 should probably be sufficient too. So whenever it stops, go a couple from the bottom, and we see we have about 1,000 cash flows. And they stop, importantly, they stop after 100. So we had 100 cash flows that started at period 3. That's why 102 is our last cash flow. And let's make sure we can verify that answer that we had before. Let's go ahead and sum the present value of all these cash flows. And there we see that the correct answer very closely matches to our math formula. All right, so now let's see what happens as we actually extend the number of periods. Let's say we go to 200 periods, for example. At 200 periods, we get much more close. We get much closer in our approximation. Right? The approximation error is only $1. And the reason that's happening, if we go way out here to period 200, you see that these cash flows are very small in present value terms. Right? Even though you're getting $220,000, it's happening in 202 years. So what's that worth to you today? 4 cents. Right? So as we add more of these, let's go back up. Let's switch our periods now to say 500. Now we get very, very close to the correct answer. And you can actually see my answer finally triggered as being correct. It says it's okay. So if your answer is not triggering as correct and it looks okay, just increase the number of periods to say 500 and it should be correct for you. And here we can see our approximation error is now well less than a penny. So the cash flows way, way, way out in the future matter a little bit, but increasingly less so. And so that's why we can really approximate the value of a perpetuity in Excel. We're just never going to get it exactly right here. All right, we say OK, and it should show us our results. And again, it shows you how many times you move the mouse. I used the mouse 51 times throughout the couple of videos I put together. So, It's okay to use the mouse. That's not a problem. Just try to use the keyboard as much as you can. All right. You can see my time, a little bit long again over multiple videos. So try to get that time as quick as you can. And good luck.